Ever wondered if you could jump from one end of the universe to another in a blink of an eye? Well, the concept isn't as far-fetched as you might think. Welcome to the fascinating and complex world of wormholes, a speculative structure linking disparate points in space-time. It's like a cosmic shortcut, a portal to the far reaches of space. Intrigued? You should be. We're about to embark on an exciting journey into the heart of this mind-bending phenomenon. Buckle up, it's going to be a wild ride. First, we need to understand what a wormhole is. Picture this, you're holding a piece of paper. On one side, you jot down where you are, and on the other side, you mark where you want to go. Now, instead of traveling across the surface of the paper, you fold it in half and poke a hole through it. Voila, you've just created a shortcut. In the vast expanse of space, a wormhole functions much like this. It's a theoretical passage, a sort of tunnel with two ends, each at separate points in space-time. Yes, that's right, space-time, because in the realm of cosmic phenomena, space and time are interwoven, so a wormhole could potentially connect not just two different locations in the universe, but two different moments in time as well. In essence, a wormhole is like a cosmic shortcut. It's a fascinating concept, isn't it? Now, how do wormholes fit into our understanding of the universe? Let's delve into the science behind it. It's all about Einstein's theory of general relativity, a groundbreaking concept that reshaped our perspective of the universe. This theory suggests that massive objects, such as stars or planets, cause a distortion or a bend in the fabric of space and time around them. So, you might be wondering, how does this tie into wormholes? Well, if space-time can be distorted or bent by massive objects, then theoretically, it might also be possible to fold it. This folding of space-time could create a tunnel or a shortcut between two distant points in the universe. Think back to the piece of paper analogy. Folding the paper brings 2 points closer together, right? Similarly, a wormhole is like a folded piece of space-time connecting two distant regions of the universe. However, it's essential to remember that these are purely theoretical constructs at this point. Despite the mathematical possibility, we haven't found any concrete evidence of wormholes yet. But what if we do? The implications are staggering. Traveling through a wormhole could potentially allow us to traverse astronomical distances in the blink of an eye. It's like a cosmic shortcut that could make interstellar travel a reality. Just imagine a shortcut between 2 points in space. The possibilities are as vast and as fascinating as the universe itself. There are different kinds of theoretical wormholes, but let's focus on the two main types: Schwarzschild wormholes and traversable wormholes. Schwarzschild wormholes, named after the brilliant physicist Carl Schwarzschild, are fascinating. They are solutions to the equations of general relativity that act like bridges connecting two separate points in space-time. But here's the thing, they're like cosmic one-way streets. You can enter, but there's no exit. It's a trip with no return ticket, a journey into the unknown. On the other hand, we have traversable wormholes. These are the superstars of the wormhole world. Imagine a cosmic highway that allows travel in both directions. Sounds incredible, right? But don't pack your bags for an interstellar journey just yet. There's a lot about these wormholes that we still don't understand. In essence, Schwarzschild wormholes are like one-way streets. You can go in, but you can't come out. So until we figure out traversable wormholes, it's best to stay on familiar ground. Traversable wormholes, however, are the real deal. These theoretical cosmic bridges could potentially allow travel from one side to the other, making interstellar voyages a reality. But here's the catch. These wormholes would require something known as exotic matter. So what exactly is exotic matter? Well, it's not something you'd find in your everyday life. Exotic matter is a hypothetical type of matter that possesses what we call negative energy or negative mass. This is essentially the opposite of the stuff that makes up you, me, and everything we see around us. This exotic matter, with its negative energy, could potentially hold open a traversable wormhole, counteracting the intense gravitational pull that would otherwise cause it to collapse in on itself. It's like using a strut to keep a heavy door open. Sounds simple, right? Well, not quite. The concept of exotic matter is purely theoretical at this point. Despite our best efforts, we've yet to find any tangible evidence of its existence. It's like hunting for a unicorn in a forest full of horses. So, while traversable wormholes represent an exciting possibility for the future of space travel, our current understanding of physics suggests that we have some significant obstacles to overcome before we can start planning our vacations to distant galaxies. Exotic matter, it's like the unicorn in the world of physics. But who knows? Maybe one day we'll discover that unicorns really do exist. Creating a stable wormhole is super tricky. This statement might just be the understatement of the millennium. The concept of wormholes is a fascinating one, but it's fraught with challenges. The most significant of these is the need for something we've never seen before: exotic matter. Exotic matter is not your run-of-the-mill stuff. It's a theoretical type of matter that possesses negative energy. In the world of physics, it's akin to a unicorn, a mythical creature that we're not even sure exists. We need this exotic matter to keep a wormhole open. Without it, any wormhole we create would collapse faster than you could say time travel. So, the first major hurdle in our quest to master wormholes is finding this elusive exotic matter. And even if we do manage to find it, we then have to figure out how to harness and manipulate it to keep a wormhole stable. These are monumental challenges that require advancements in our understanding of the universe and breakthroughs in technology. But let's take a moment to dream. Let's imagine we overcome these challenges. What then? Well, the opportunities would be nothing short of mind-blowing. If we could create and control wormholes, we'd have the ability to travel across vast distances of space in the blink of an eye. We could explore distant galaxies, witness the birth of stars, and maybe even encounter other forms of life. The possibilities are endless and incredibly exciting. Think about it. We could zip around the universe faster than light, discovering new worlds and civilizations. We could redefine our understanding of space and time and push the boundaries of what's possible. Yes, the path to creating a stable wormhole is filled with obstacles. But if we can overcome these challenges, the rewards would be astronomical, literally and figuratively. So, let's keep dreaming, keep exploring, and keep pushing the boundaries of our knowledge. After all, who knows what we'll discover next? Imagine the possibilities for space travel. In a nutshell, wormholes are like magical tunnels in space. They present us with a tantalizing possibility, a shortcut through the universe, a door to the unimaginable. But as we've discovered today, the reality is a little more complicated than the fantasy. These cosmic phenomena aren't just a matter of folding a piece of paper and poking a hole through it, although that's a great place to start our understanding. The science behind wormholes, rooted in Einstein's theory of general relativity, suggests that the fabric of space and time can be distorted and bent by massive objects. Under this theory, the universe is not a flat piece of paper, but more like a dynamic landscape shaped and reshaped by the celestial bodies within it. And in this landscape, it might be possible to create shortcuts, wormholes, between 2 points in space. But not all wormholes are created equal. We've learned about Schwarzschild wormholes, the cosmic equivalent of a one-way street, and traversable wormholes, the kind that could potentially allow travel from one end to the other. Traversable wormholes are where the magic really happens. But there's a catch, as there so often is with these things. To create a traversable wormhole, we need something called exotic matter. This is stuff with negative energy, the kind of matter that breaks the rules, that goes against the grain. The trouble is, we've never actually seen exotic matter. It's as elusive as a unicorn, a ghost in the machine of our understanding of the universe. Without it, creating a stable traversable wormhole is a bit like trying to build a sandcastle with dry sand. Despite these challenges, the potential rewards are huge. If we could harness the power of wormholes, we could potentially zip around the universe faster than light. We could revolutionize space travel, visit distant stars, and explore the far reaches of our universe. So where does this leave us? With a universe full of mystery and potential, with questions unanswered and doors unopened, it leaves us with the thrill of discovery and the joy of exploration. It leaves us with the knowledge that we have so much more to learn. Maybe one day we'll be hopping through wormholes like it's no big deal. The universe is a big place, full of wonder and mystery, and who knows what we'll discover next. Until then, keep dreaming big and exploring the universe.